Hello and welcome back to the fourth video in the series of the mathsonlinetuition.com videos where we try to complete and go through the Edexcel books. We'll be carrying on with chapter 1 from C1 and we'll be going through sections 1.5 and hopefully sections 1.6. So let's get straight into it. Section 1.5 discusses factorizing quadratic expressions. Now, quadratic expressions are something that you will have come across when you were doing GCSEs. Definitely if you were in higher courses, mathematics, GCSE higher courses, you'll have encountered quadratics before. For those of you that haven't, please go through the GCSE explanation and working out for quadratic expressions. I feel as though they'll explain things in a more simplified version than A-levels, or alternatively you can just continue listening to this video and hopefully you'll understand it through this more advanced way of explanation. So there's three different ways, and this particular way presented in the chapter is using the method of identifying A, B and C and deducing a number that is given by multiplying A and C, but at the same time the two numbers that add together to give B. So again, you need to identify A, B and C using the general form which is stated here, okay, and then from that number you need to then reintroduce it into the equation and then once again factorize. I should say that you can now start to see that some of the techniques that we've already started to learn are being used, and again it goes back to what I mentioned before about the linearity of mathematics, that as soon as you learn something you start implementing it. So let's look at question B in this example, x squared minus 5x minus 6. We'll just briefly run through it. Again, so we can identify from the general form here that A is going to be equal 1, B is equal to be minus 5, and C is going to be equal to minus 6. So A and C is going to be minus 6 because of the fact that A is 1 and C is minus 6. And then again we can ask ourselves what number is also going to numbers is also going to give us minus 5. Well, if we look here we can see that those two numbers are going to be in fact minus 6 and plus 1. So again, this is just trial and error. You could have said 2 and 3, but obviously in terms of the signs, having minus 2, minus 3 and going through all the different combinations, you'll come to realize that doesn't work. So you come back to, or you realize that minus 6 and 1 plus 1 work. So then you insert them into the equation as is done here, and then again we then begin to factorize. So we can see that this x squared and the x is used together, and they've taken out the x, and likewise for the latter part of the expression you can see that the 6 is taken out and what's left has been put in the brackets. Now this is the key point here, is that you'll notice that x plus 1 and x plus 1 are identical, and that's been intentionally done to give us the terms outside of the brackets which actually form their own bracket in the next step. So this enables us to extract the second bracket. Now if we just scroll down ever slightly, we'll also see that there are other examples that follow a similar theme and a similar pattern. For this particular equation you can also see that if we had a 0 here on the other side, we can see that x would be equal to minus 1, x would be equal to plus 6, and so we could check again. This is with the assumption that this was equal to 0 on the right hand side, and this would then verify for us whether we did in fact have the right x terms. or x values. So we'll just move on, and I want to point out f. One thing that is very good about the Edexcel book is that as you go through different questions, they'll sometimes emerge a particular technique or a particular method which you'll have to use from one of the questions posed, and then it will always be highlighted in a black color in a very obvious place for you to notice that there is a particular type of understanding you need to incorporate within your arsenal of tools in order to tackle questions. So for example, here we can see that if we look at 4x squared minus 9y squared equal to 2 squared x squared minus 3 squared y squared, we'll appreciate that in terms of the unknown values, x and y are not the same, evidently. And again, we have even number here and odd number here, so we won't have any common factors. But one thing that you'll notice is that we have what's called the difference of two squares. So actually we can still factorize them by giving us, which gives us this solution here. So again, the rule is x squared minus y squared, and then x plus y inside one bracket and x minus y in another bracket. We can see, obviously, because in our particular case we have 2 and we have 3 in front of the terms being the coefficients in this particular case, we also insert them with regards to this specific question. So let's just do a simple question, because some of these questions now are getting a bit more long-winded. So let's just take a random one. Let's say we have question here 10. Okay, so let's do question exercise 1E, and that's question 10. Okay, and question 10 is x squared plus x minus 20. Now we can see here, using the general form that we've used beforehand, that ax squared plus bx plus c would mean that we have our a being equated or equal to 1, b being equal to 1, and c being equal to minus 20. Now we need to think of a number that gives us minus 20 from the AC, but at the same time is added together to give us 1. Now for a lot of people, they might at first glance think, well, how am I going to get a number that gives us 20 when multiplied but added together to give us 1, because of the perhaps broadness or difference in the number, the range in the number. Well, actually it's very simple, and the answer would just be 5 and minus 4, because if we were to multiply these two, 5 times minus 4, we'd see that we get minus 20, but if we were to add them, we'd see we'd get 1. So it's as simple as that. So now, as we mentioned before, we need to install these new numbers into our original equation. So now we'll have x squared, but this time we can say that we'll have minus 4x, and then we'll have plus x, and at the same time we'll include that minus 20. So now here comes the part where we start to factorize. So let's look at the first two terms, and then we'll leave the latter two terms, or the second two terms, as another set. So between the x and x squared and the minus 4x, we can tell that there is a similarity of an x and an x only. So we take x and then we're left with x minus 4. Now we mentioned before that this bracket will always reproduce the same bracket for the second half, so we can already install that. Now this makes things much easier for us, because now when it comes to figuring out what number should be outside, sometimes we could just simply have a look at the equation and we can notice that there is a 5 that will sit comfortably outside, and it's also a plus 5. So now we can say x minus 4 for certainty, and then taking the terms which stand outside of the brackets, and then we can say that we'll have x plus 5. So now you've factorized this particular example, and again, if you want to make sure that you've done it right, all you can do is just simply, once again with the arrows or using your own technique, make sure that you have accounted for all of the terms by expanding. And if you get this original equation which we've had here, then you know that it's correct. So now let's move on to the next part of the chapter 1, and it's a revisit of something we'd previously done. I believe it was in episode 2, which is indices. Now the only new addition to this particular section is the fact that it talks about rational exponents, but more so it's this particular rule I want to make mention of and pay very close attention to. A to the power of 0 is equal to 1. Now as you go through the mathematical levels, you'll always end up using these various rules, and sooner or later it'll become your bread and butter and second nature to you. One very important rule, and I've used many times throughout my university career, is a to the power of 0 equals 1, regardless of what the number is. Now the number could be, I don't know, let's say 100,000, okay? So 100,000, but if it's to the power of 0, it's going to be equal to 1. Or we can have 1 million to the power of 0, and again it will be equal to 1. So this is a very important part of the power of the rules which we need to recall. If we just scroll down, again these questions are very clear and can be done in your own good time. It's just expanding on what we learned before about the rules of the indices, just giving you some fresh numbers to play around with. And if we go down, we can see that now we've come across what is entitled as surds. Surds again are what we can appreciate to be numbers that are square rooted, and again they have their own system of evaluation. So let's clear our interactive whiteboard and play around with some surds. So in section 1.7 it will talk to you about the following. You can write a number exactly using surds, e.g. the square root of 2, the square root of 3 minus 5, and the square root of 19. You cannot evaluate surds exactly because they give never-ending, non-repeating decimal fractions, e.g. square root of 2 equals as such. The square root of a prime number is a surd. So again, as we mentioned before, prime numbers are numbers that can only be divided by themselves in 1. This is something that you should know, so I don't need to elaborate anymore. But here, let's look at these particular rules. So for example, it says that the square root of a multiplied by b equals the square root of a multiplied by the square root of b. And likewise for a division equivalent, the square root of a divided by b is equal to the square root of a divided by the square root of b. So this is pretty clear, and again throughout the next examples you can see some numbers that have been used to help you appreciate how to simplify some of these questions. So let's just go through one very quickly. Let's take the first one that meets our eye, which is a. So if we ask ourselves a, what's the square root of 12, and how can we simplify it? Well, as is from the first rule here, let's title it star and this one star star. We can see that we can break down 12 into two terms, which is 4 times 3. Now I know obviously you could have done 1 and 12, but that doesn't really help our case. As we move on you'll see why. Or we could have done 2 and 6, but again that wouldn't really have helped our case. The reason why we chose 4 and 3 is because if we use our example, our expression here, you'll notice that we get 4 and we get 3, as is indicated here in the example. And once again, we can then simplify further by saying the square root of 4 is 2, and the square root of 3, well, is going to remain as the square root of 3. Now, once again, I'll explain why we couldn't have used 2 multiplied by 6, because this would have given us the square root of 2 and the square root of 6. Now again, we could have said that this is equal to the square root of 2 and the square root of 3. Okay, now this is as far as it goes. We could, in theory, have multiplied the square root of 2 by this square root of 2 to give us 2. Obviously, as you can appreciate, this is a longer method with a single more step, and obviously in a very time constrained exam, perhaps you don't want to add to the number of steps that you may have to do, because this could add to the number of risks, the number of errors that you could encounter in your questions. So that's the simple run through of the first example. Now if we just carry on and scroll down, you'll see that you have a number of examples that are given here for you to run through. We'll just finish off with section 1.8. In section 1.8, you'll notice that you have some rules that they've outlined for you to appreciate when you approach surds in a more advanced manner. Let's carry on with the reading. It says the rules to rationalize surds are fractions in the form of the square root of 1 over a, multiply the top and the bottom by the square root of a. Fractions in the form 1 over the square root of a plus the square root of b, multiply the top and the bottom by a minus the square root of b. Fractions in the form of 1 over a to the a minus to the minus square root of b, multiply the top and the bottom by a plus the square root of b. Now again, just to summarize what it's said here, and this is a new idea that you'll have to grasp, is that whenever you're encountering a fraction in any one of these 3 particular forms, okay, the rule to resolve them is by multiplying the top and bottom by its respective solution. And again, when you carry out these tasks enough times, you'll come to realize, or you'll come to notice them at first glance. And again, it becomes second nature to you to identify which form it comes in, and for you to be able to provide the solution to it. And again, this takes practice, and there's no one out there that doesn't need to do this a few times for it to settle into their mind. So don't be shy to go through a number of the questions. As you've seen in this book, it generously provides a lot of questions for you to go through. So let's see an example here. We've got this example here, B. So as we can see, the question is 1 over the 3 plus the square root of 2. So let's look back at our forms here proposed to us on this particular section, and we can look at perhaps what is best is the sign, because that will give away, depending on this identification, obviously we know it's not going to be this one here, which one we need to utilize. So it's this particular one. Another hint that I can give is whenever a surd is presented in a particular form, okay, it will be multiplied by the opposite of that form, charge. So for example, here you'll have a negative, okay, and likewise in this in the third rule, if you have a negative, you'll multiply top and bottom by a positive. So it's always the opposite. You could say the opposite diffuses it. Okay, so carrying on with this example, let's multiply the top and bottom by 3 minus the square root of 2. 3 minus the square root of 2. And as is the case with multiplying fractions, this is something that you would have done from a very early age. We multiply 3 plus square root of 2 by 3 minus the square root of 2, and we're left with 1 times 3 minus the square root of 2. So on the top it's pretty simple. That was 3 minus the square root of 2. And again, obviously you'll know from previous examples is that we have now started to utilize expansion. So 3 multiplied by 3 gives us 9. 3 multiplied by minus square root of 2 is minus 3 square root of 2, plus square root of 2 multiplied by 3 will give us this, and plus square root of 2 minus square root of 2 will give us minus 2. Again, the negative comes from here, the negative being multiplied by the positive, and again the 2 multiplied by 2 will give us 2. So then we simplify, again using all the ideas we've used in the past, which will give us 7 as the denominator, and of course, as we originally discovered before, it will give us the 3 minus the square root of 2 on top. So that was a very brief overview of how to resolve the surds. And again, you can go through some of the other examples here, for instance C, which utilizes both the positive and the negative. So in this particular case, you can see that all that they've done, once again, is use the positive in both cases. And the reason for this is, once again, that we follow the rule whereby the question C poses a form whereby the denominator has a negative sign within it. Okay, so don't let the top puzzle you or throw you off, or the numerator, to be more specific. It's the denominator that we are more interested in. And so you can see now that they have multiplied it by the plus sign, and again expanded it. And similarly here, you'll recall for this particular denominator, 5 minus 2, the way that they've achieved that is by using the rule that we discussed earlier on in the book, which was that if we have x squared, okay, minus y squared, that we will have x minus y and x plus y. And we can notice that in this specific question we had the question as the square root of 5 minus square root of 2 and the square root of 5 plus the square root of 2. So this would give us 5, the square root of 5 squared minus square root of 2 squared, which would give us 5 minus 2, which will eventually give us 3, which is seen here in this answer. So that's really it. It's really that simple. You just now need to go through some of these questions on your own, identifying what needs to be multiplied by what. Again, not being thrown off by the different signs. We already discussed what you need to do by looking at the denominator. Okay, so go through some of the harder questions in your own time. I believe that the answers are posted online. I may post some of the answers on the mathsonlinetuition.com website to enable you to search for the answers to ensure that you're correct. However, I do believe you can find them online by just googling this particular book. So that's the end of chapter 1. The rest of it just identifies some of the different questions amalgamated together and gives you just a different range of challenges to broaden your skills and hone in on your different abilities to jump from different methods that you need to utilize. And again, it just gives you some more formal and perhaps difficult questions to challenge you. But again, a tip I'd highly recommend is don't be scared about big numbers or mean looking equations. They've done this, the writers of the book have simply done this to try and challenge your mind sometimes mentally, but also psychologically. In terms of the questions, some of them actually turn out to be a lot easier, even though they look difficult compared to questions that look easy. So don't be frightened, and as we always say, give it a challenge. If you don't try it, you'll never get it right, but if you try it, you may get it right. So this is a summary of key points, and this pretty much, as it's entitled, summarizes all the key points that you need to know before you carry on. It's all the rules that have been highlighted and discussed in the previous subsections, and I would highly recommend that you take some time, even pause this video, to look through all these different methods and techniques. I would also suggest that you write them down on a piece of paper somewhere, and perhaps stick them up on your wall, or perhaps put them down on flashcards, or maybe take a picture of them on your phone and go through them daily until you've memorized them and until they become second nature to you. Because now that you've learnt these particular skills, you won't actually forget them or stop using them as we pass on to the next few chapters. You'll be using them even more and more, and they'll appear not in this particular pattern, but they can appear in random. For example, you might have to use this particular rule at one point, and in another section you might have to use this particular rule. So please do follow the instructions and the hints and the tips that we provide you. So I think that's all for this video. I really want to get chapter 1 out of the way so I can continue with the rest of the book. So for now, thank you very much for listening. Thank you very much for being with us, and we'll see you next time for our next episode.